Just 7 years ago in 2017, I began my journey into learning data science. While most of my friends were grinding LeetCode and trying to get straight A's, I was reading the latest papers in deep learning and neural nets, and I really enjoyed it. Although my learning pathway was rather inefficient, it was slow and not very well organized, I eventually got pretty good at this stuff, so at the end of my undergrad degree, I worked for a medical startup in the computer vision field and actually published an important paper. Now looking back, the pathway I took was completely wrong. It wasn't the wrong stuff, but the order and the way I did it was just not good at all. So I would not recommend doing it the way that I did. It only really worked because I just absolutely persisted and gave it every single thing I had. And even if I had picked the right pathway, I still wouldn't do it again today. It's just completely different in 2024. In fact, it's changing every single day. You might be tired of hearing people say this, but it's so genuinely true. Data science and machine learning and all of this stuff, it is changing absolutely constantly. Now sure, many of the core skills are the same. Python, SQL, that stuff is never going to go away. Even if AI starts to automate these things, and it is, Python code is still going to be there. At least someone's going to write it, whether it's you or the machine. But what's so interesting here is that data scientists are causing the automation, and they're even automating themselves. The tools available today, most notably in generative AI, have completely changed the data science landscape. You can learn so much faster today if you know the pathway and the know-how, and in this video, I'm going to tell you. This is how I learned data science again, if I had to, right now in 2024. Now, firstly, I need to tell you the skills that are required to get the job done. There is many skills, and this is going to be a long list. Expect this. You're watching a video on how to be a data scientist, and it's changing and growing every single day. Learn the skills, and you will get there. Now, there's many ways to learn these skills, and I'm not able to cover them all in this video, both free and paid, and I think there's benefits to both platforms. Here are the skills that are required for any data science job today. I won't be able to cover every single one because even if you look at one job there, I'm probably not going to cover all of the skills for that. There's just too many and too many buzzwords, but I will provide you with the general tools that are most likely to come up, as well as the ones that are most versatile and transferable to the other skills that you might need to learn if you are on the job or preparing for another. In order, here are the steps one by one to learn data science. Number one is mathematics. I know, a boring and frustrating way to start. The language looks really daunting. It doesn't even seem useful because on the job, you're coding and not doing math. I know. I agree with all of those things. You have to think like a math person here, and knowing the basics of linear algebra like vectors and matrices, a little bit of calculus like derivatives and maybe integrals, probability theory, hypothesis testing, and some statistics, that would take you very, very far. 100 or 1,000 years from now, math is always going to be math, and you should just learn it. Also, some of this stuff, especially the probability and statistics, can get asked in interviews, so you do want to have an understanding there. Okay, number two, you need to learn how to code. Wow, another big shocker, eh? I know. But seriously, you do have to learn how to code. And a lot of people just kind of jump into data science being like okay or sort of okay at programming, and it is the limiting factor for so many people is that they haven't done like object-oriented programming, software design patterns, all of this stuff that has nothing to do with data science and is fully just in software engineering practices. Do coding before you do data science, get as good as you possibly can at coding, and then start to do the data stuff. And here I really have to go on a small rant about why you should not learn R. And this is my opinion. If you want to, then by all means. However, I will tell you, Python is a general purpose language which is great at data science as well as great at everything else. It even makes websites. There is nothing that R does other than statistics. It can do other things, but no one will ever use it for those things because it is terrible at them. Learn a language like Python, C++, Java, C#, whatever you want. One of those languages that is good for general computing. You can make applications in it. I would recommend Python because you're trying to learn data science. If you just learn R, you will be tempted to stick with R, and then you're going to get caught and refuse to do other stuff. So get good at programming through a normal language like Python or Java or something like that, and then do the data work later. Number three is SQL, which you've likely heard is absolutely essential for data scientists, and it is for pretty much anyone working with any sort of data. So anyone coding anything, SQL is essential. SQL and tabular data just tends to come up with no matter what you're doing. So this is one of the best investments of your time ever because if you ever go down part of the data science pathway, I want to say that you are able to do other stuff, which is again why I'd say don't learn R right now, because if you do, you're forced to do data stuff and it's not going to be helpful elsewhere. If you're learning Python and you realize, hey, I actually want to build websites, that's incredibly valuable. Same thing with SQL. It's a very good investment of your time because it will be useful everywhere. And there's actually a lot of great theory here. SQL itself is complicated, meaning there's a lot of different functions you can do with it. But outside of SQL entirely, there's a lot of relational database theory. And taking an entire course on that, there's actually like 1,000-page books you can read just about relational database design. Nothing to do with SQL at all. And honestly, as AI continues to automate more and more of the writing of the code, it's going to be more important than ever, both for yourself and for the benefit to companies, that you understand the high-level concepts. And that's what relational database theory and SQL is all about. And by the way, before you ask, MySQL, Oracle, Postgres, it really doesn't matter. People like to say that there's a difference because there is a difference, but it's very small. In fact, 99% of SQL flavors are exactly the same. You should probably start with the most general one, which is SQLite. Okay, now we're on to number 4, and this is where you'd learn Python's essential data libraries like NumPy and Pandas. SQL, like you would have just learned, deals with tabular data. Pandas does the exact same thing, but in Python. Tables are considered tabular data because they have rows and columns. Just a column or a list of values would be one-dimensional data. NumPy takes this further and allows n-dimensional data, so 3 would be a cube of data, 4 would be multiple cubes of data, and 5, it starts to get pretty hard to visualize. Now you might be wondering why this stuff even comes up, like why would you have a cube of data or multiple cubes of data? It starts to get pretty weird, and that's actually the stuff that you'll start to deal with when you do deep learning. Images are 3-dimensional objects. If you have a batch of images, well, that is multiple 3-dimensional objects, aka 4-dimensional. Deep learning and neural networks love this type of data, and so it's essential to get comfortable with NumPy's n-dimensional arrays. Specifically, shaping and transforming these arrays is absolutely vital. Other essential Python libraries that often interact with NumPy, as well as were built on top of it, are Plotly, Seaborn, and Matplotlib. And while it's not overly complicated, it's a little bit different than working with an IDE. You'll definitely need to get comfortable with Jupyter Notebooks. Also, if you haven't already at this point, make sure to interact with Python and SQL together via the SQLite library. SQL is actually seldom used on its own. It's very commonly just sent as a string via a programming language like Python or Java. Okay, next up is more data visualization like Plotly and Matplotlib can do, but actually outside of Python for once. While Python's visualization libraries like Matplotlib and Seaborn are great for creating quick graphs, there's better visualization tools like Power BI and Tableau. I think the big difference here is that Tableau and Power BI will really bring your data to life, making so that anyone can understand it. And that's what you want, because when you're making visualizations, sometimes it's for the data science community, like if it's in your team, but most of the time it's to external stakeholders or other business people, and they're not going to understand the math stuff as much as you. And if you're going to take away anything from this video, remember, please, the goal with visualization is to help others understand, not complicate things. I think people get this mixed up all the time. Fancy PowerPoints, these fancy graphs, they don't make sense if you don't already know what they're talking about. And in a 20-second presentation, glossing over it, you need to be extremely considerate of the people in front of you. Say what the x-axis is, say what the y-axis is, say what the colors are, say why there's a curve. People don't do this, they just show here's the results, and it's very frustrating. Okay, but we're still technical people, so number 6 is rather technical. As data got larger, we started to call it big data. Sounds pretty natural, right? Well, there's an issue with big data. It doesn't fit on computers because computers are finite devices. We can add more computers, and that's exactly what we do. So we need to learn concepts like MapReduce, parallel computing, and the high-level frameworks that use those like Apache Spark and Beam. Simply put, these technologies allow us to seamlessly interact with the data as if it wasn't on multiple computers, even though it is. Sounds kind of weird, but genuinely, look at some Spark syntax here. It doesn't look so crazy. To us, it's like it wasn't even spread out at all. Apache has a lot of Spark code under the hood that allows this to interact so well. Understanding distributed computing is essential for dealing with large-scale analytics, which is what pretty much every company is dealing with. And if you're talking about the biggest companies, they're talking in petabytes and multiple thousands of petabytes. And because big companies require this, if you are interviewing for any sort of software role, and definitely as something like a data engineer, they are definitely going to ask you you something to do with distributed computing, or at least designing a scalable system. You may have heard of the system design interview. They will talk all about that. Okay, quick pause here. I know this list is really starting to build up, but we're about halfway there, so keep it going. If this feels daunting, I wouldn't blame you. Don't worry about it. But luckily, because of today's sponsor, we have a very nice way to learn the vast majority of these skills. So here's a quick word from today's sponsor, which is Scikit-Learn. Specifically, Scikit-Learn's data scientist program is something I would highly recommend for anyone looking to make their mark in data science. Designed by leading industry experts, their comprehensive program covers everything from Python to MySQL to ChatGPT, through to machine learning and deep learning, all the way to cutting-edge technologies like recommender systems. Now let me be clear, this is not just another online course. This program offers live online classes delivered by industry experts in collaboration with industry giants like IBM. I found this really helps keep the consistency in the learning, which is crucial given the amount of material necessary to complete this long journey. They really do streamline this process for you, and I bet you'll actually be excited to get to work. Honestly, just imagine gaining proficiency in essential tools like NumPy, Pandas, and visualization techniques with Tableau and Power BI. Everyone needs to learn the skills, and there's a lot of skills to cover in this realm. In Scikit-Learn's program, you even get to learn those annoying tools like Excel that seem dated, but let's be honest, are probably going to come up in every single job that you do. You'll rarely see me talk about Power BI, but it's a Microsoft product. It's in their suite. It's going to come up as your job as a data scientist. Scikit-Learn's program actually gives you a professional certification at the end of the program that you can share on your LinkedIn and resume, which pretty much every employer is looking for these days. And as you may have seen, there's a lot of competition these days, so stuff like this is really going to help set you apart from the wannabes. Check out the link in the description below to hear more about Scikit-Learn's data science program. Now back to the video. Number 7. Alas, we have come to where we learn machine learning. You'll need to grasp core concepts such as the bias variance trade-off, cross-validation, linear regression, and binary classification, and then move on to applying these algorithms on real data in Scikit-Learn. This knowledge will even enable you to create models that can predict the future, otherwise known as time series forecasting on time series data, and this is one of the most sought after skills in any regular company like a bank. The journey through machine learning is definitely one of trial and error. You will do lots of things that don't work, and you will do lots of things that do work. It takes a lot of guessing. There's so many different ways to think about a problem, different architectures, different models, different hyperparameters that you can tune. There's so many different things that you can change when you're doing machine learning, and you should have fun with it. Now, there's a lot of different buzzwords I could throw out here: supervised versus unsupervised versus reinforcement learning, clustering, dimensionality reduction, there's regression versus classification. And while I definitely recommend learning that, this is also the time to gain practical experience through competitions like Kaggle. People get really good at this, a lot better than I ever did. You could absolutely have a blast with that. Lots of people do. There's so many different projects. I generally go down the project route of just having fun with it and doing whatever you want to do. Whatever works for you here, have fun with machine learning and play around with it and learn. Just make absolutely certain that at this stage you have learned the bias variance trade-off and you could explain that very well. You will and should get asked that in a machine learning interview because it is by far the most important thing to understand. Okay, number 8. Deep learning takes machine learning to the next level. Now, the neural network architectures I'd recommend learning in order are feed-forward neural networks. That's basically the vanilla, just basic neural net. Learn backpropagation and do some backpropagation to train these neural nets. Really, really important. After that, learn convolutional nets and recurrent neural networks. And finally, learn transformers, which are taking over everything, most notably large language models right now. But even more than that, transformers are kind of doing everything today. It's pretty crazy. Make sure you learn those neural nets. Now, deep learning is particularly resource intensive. They need GPUs and generally big GPUs. Not just that, but also a large amount of RAM. So if you are working on a $500 laptop, probably isn't going to train on that very well. Therefore, you will probably end up using some sort of a cloud system like Kaggle, AWS, GCP, Azure, something like that to train your models. And that's very good because learning those skills is going to be more important than ever. More and more work is going to be away from your computer and onto a cloud because these big companies are just more and more taking over. I'm okay with that. It's happening. Let's just embrace it. Okay, number 9. So as we saw, largely because of these big companies, pretty much everything is getting automated these days. And machine learning is no different. There's actually a particular type of machine learning called auto ML, which is literally just automated machine learning, which is going to do your ML tasks for you. Currently, these are usually Python libraries like PyCarray, AutoSCLearn, and just AutoTrain. These are generally just things that you import into Python, pass your data, and it's going to train the best model. It's still important to learn all of the things that it's going going to do to make your model good so that you can adjust it and you know the theory. But in practice nowadays, we actually don't really do that much. It's mostly done automatically. In particular, these processes abstract a lot of the tedious work a machine learning engineer would do, including cross-validation, understanding why the model works if you chose one that's not a black box like linear regression. There is model selection and hyperparameter tuning. There's so much stuff that it's just going to immediately do for you. I highly recommend you check these out. They're actually really cool. Number 10 is MLOps, or machine learning operations, and it's basically just the stuff that a company does. It's machine learning, but actually as a process and not just as a fun hobby. This often accompanies model deployment, API and REST frameworks, and you might even do some HTML and CSS stuff to make this pretty and interactive. And I'd say for the most part, MLOps is just taking your machine learning model out of a Jupyter notebook and actually making it usable, so usually into an API. Now this can involve everything from version control to testing to CI/CD, continuous integration and development. There's even stuff like Docker if you want to kind of containerize this. There's a lot going on here that you can learn about, and I recommend that you do as much as it interests you and a little bit to take your model into production. But don't feel like you have to learn all of this stuff. This is stuff that you often would learn on the job, and they're not necessarily going to expect you to be a master of MLOps on their platform. They want you to be good at the fundamentals and to be good at computers, absolutely, but you don't need to master all of this stuff before you get there. My biggest recommendation here is to make sure you have some sort of machine learning available to the public, generally at a link you can just type in the browser. And this doesn't have to be paid. There's actually lots of free or very cheap ways to host a website. pythonanywhere.com is a completely free way to do this. GCP, AWS, and Azure will charge not very much to host a simple API or website. Just make sure that you have something deployed on there. That is most of the MLOps that most of the companies would want. Okay, lastly, number 11 is the new stuff. The stuff that probably is coming out as you are listening to this. The ChatGPTs, the Llamas, the Devin. Devin just came out. This stuff is crazy. Specifically, if you're not already familiar, I definitely recommend learning something called reinforcement learning from human feedback. If you don't know any reinforcement learning, then that might be a little bit tricky, but I would learn the basics of that, and then you can see how these models are really learning and getting so good at doing what they do. Now, these technologies are changing how we work every single day, and I try my best to keep up with them. Honestly, my recommendation here is not to study, but to follow people on LinkedIn and Twitter and whatever, just to stay up to date with these things. All you really need is a flashy video, 45 seconds, that says like, there's this new thing out. You have to be aware with the technologies so that you can utilize them before all the other people get to see them. Okay, so right here on the page are the 11 skills. I would recommend learning those in that order. Assuming that you've learned those skills, let's move on to how I'd prepare for interviews. Now, the number one thing you are almost guaranteed to get asked if you are in a data science interview is an SQL and database related question. Most likely what they will do is show you the schema of a database. Schema is basically just the interactions of the tables. It's a little picture that shows you what the database represents. They will probably give you this diagram and ask you to come up with the appropriate SQL query to answer the question and get the data that they want. If you're looking to practice this stuff, LeetCode has lots of SQL questions on there. That's probably what I'd recommend. There's lots of different Learn SQL websites as well. Secondly, you will likely get asked a data structures and algorithms related question. Please don't complain about the process. Why are they asking these LeetCode problems? This is so hard. This isn't relevant to the job. Maybe it's not. I still think that it's helpful at least a little bit. They likely will ask you these questions. Not all data science folks will, but a lot of them will, so I would prepare it. And you might as well prepare it because if you want to do any software related job, it's just going to come up. So I'd put in the investment and learn DSA. Arrays, strings, heaps, hash maps, hash maps, hash maps, hash sets, hash maps, and dynamic programming and graphs. Lots of different data structures and algorithms, which you should learn. I would recommend just doing LeetCode, or even the NeetCode roadmap is great as well. Thirdly, you may get asked a machine learning fundamentals question. This is probably going to be in the form of either looking at a graph and interpreting machine learning results, or it is going to be explaining something like the bias variance trade-off, or some high-level statistics conversation that tends to come up, maybe cross-validation and why you'd split into train and test and validation sets. nets. They might also ask you a more open-ended question, like they have some problem they're trying to solve, and you could describe some model with maybe the architecture, at least the output and input of that model, so that you could hopefully solve that problem if you get your data. Lastly, you may get asked a probability question, and you probably won't, so I'd cross your fingers that you don't, because you don't want it, and you probably won't. But if you do, it will be in the space of maybe Markov chains. That's a probability concept. Definitely Bayes theory just comes up a lot. Just memorize Bayes theory so that you can use it. At least write it on the board if you ever get asked that, because that's at least a point right there. Honestly, these types of questions are usually reserved for like the crazy AI startups or hedge funds, or some of the FANG roles might ask this stuff. I wouldn't worry about it too much. One last thing for the interview conversation, obviously behavioral stuff is going to come up. They will assess your behavioral ability at pretty much every step there. They are human beings. They want to get to know you. They want to just assess who you are. They are the ones possibly inviting you into their company, and the role that you play mentally and behaviorally is insanely important to them. Probably a lot more important than the salary, to be honest. They need to make sure that you're going to be a good fit and actually provide value to the company. I'm not going to give you that much advice here on saying how to be good behaviorally, but make sure that you can just talk to people. A lot of you guys can't, and you know, that sounds blunt, but it's genuinely true. Get yourself in front of a camera, maybe a microphone, record yourself, do it until you get comfortable, talk to real people, talk to the grocery store folks. Honestly, it helps a lot more than you might think. The last section here is how I'd apply to companies. So you've learned your skills, you've learned your interview process, you're ready, you just need to apply. So how would you do that? Well, the first thing that I would do when I'm applying is just go to LinkedIn and go to the easy apply. So it's like just a little check mark there for a filter. You can check easy apply. You can press so many of these, you know, search data science, search data analytics, search software, search whatever you want to, and then you can just apply. You just need to upload your resume once, and you can really send like 100 of these a day if you really devote yourself to it. You can get into the thousands of applications here if you actually spend your time on it. You just send so many applications out. They're not great applications. Lots of these people are doing them. There's a lot of competition, but you're really spreading your chances here, and I think that's a great thing to do. Now, since we are doing data science here, a job that pretty much everyone does now, you can simply just search top companies. That'll of course come up with Google, Microsoft, Facebook, Amazon, everyone. All of those companies hire thousands of people every single year, thousands of data professionals every single year. There's also the banks, the insurance companies. Go to their company website once you see the name there, search it up, and just apply. Now, this is a lot slower. It's irritating. You often have to work with Workday and these annoying sort of application stuff. I get it. It's frustrating. This thing annoys me too, but it is worth it, because since it's annoying and since it's frustrating, well, that means that not a lot of people are going to do it. And so you definitely have to be the one that does that. And if you do it enough times, you're definitely at a huge competitive advantage. And here's one that you might not expect, but is a huge hidden gem here, is these incubators for startups like Y Combinator. There is a lot of them, especially locally. I live in Toronto. There's a lot of these Toronto incubators and different associations with startups. I would definitely recommend working for a startup. I had an absolute blast when I worked with mine. It was super fun. Got to do some really important and interesting stuff. Yes, there's all that annoying stuff like, oh, job security. Job security is a myth, guys. It's all in yourself. You have to have the skills. You have to have the work output, and just do what you need to do. Working at a startup is an amazing time, and I strongly encourage you to do so. Okay, guys, that's all for today. Make sure to check out Scikit-Learn's data science program at the link below. Have a great day, guys. Bye-bye.